This fuel injector looks completely different from the schematic we were provided.
Check the serial number against the Peenemünde manifest.
What do the manuals say about the gyroscopes?
It mentions Kreiselgeräte, high-precision components.
We must examine the turbopump assembly's efficiency ratios shown here on the cross-section diagram. This is critical for the trajectory calculations.
This dimension is still showing in millimeters.
Convert it to inches and verify the tolerance on the slide rule.
The carbon content is higher than expected.
Check the tensile strength figures against the captured documents.
Look at this injector port. The erosion pattern suggests a much higher flow rate than anticipated.
Yes, and the milling on the bearing surface is incredibly...
Look at this injector port. The erosion pattern suggests a much higher flow rate than anticipated.
Yes, and the milling on the bearing surface is incredibly...
The heat-affected zones show significant material changes.
Precisely. The X-ray fluorescence confirms the coating breakdown right at the throat.
This symbol here, I believe it signifies a stabilization capacitor.
Yes, but the voltage rating seems low for this stage of the guidance system.
Okay, carefully lower the section. We need perfect alignment on the laser guides.
Torquing the main bolts now.
Ensure the specifications match the schematics exactly.
There's a leak, T-junction on the starboard manifold.
Confirmed. Pressure starting to drop at 550. I'll note the location.
Approaching 3,000 RPM.
Vibration levels are stable. Increasing steam pressure now.
This static test stand represents the future of American rocketry, forged here in the New Mexico desert.
Channel 42 confirms continuity.
All right, seal that junction box tight. We can't risk dust ingress.
Attention, attention. Initiating emergency shutdown sequence.
Acknowledged. Pressure dropping.
Ensure the grounding strap is secured first. Static discharge is not an option here.
Understood, instructor.
Control, flow rate is nominal.
Acknowledged. Continue transfer sequence. Monitor levels closely.
Conductor to all stations, confirm readiness for propellant load.
Systems nominal, telemetry is green.
Weather is holding steady. Roger that.
Continuing countdown.
The data aligns with the guidance figures.
We are seeing the expected thermal patterns.
This confirms a successful static fire.
The specific impulse calculation comes out lower than the predicted value.
Let's cross-check the propellant consumption rates against the flow meter readings.
Here's our lyses. This layout, based on the Peenemünde concepts, optimizes the production flow into the high bay.
We need that gravel base on pad 4 by 1600 hours. Over. Roger that. Sending trucks now.
All right, bring it up slow. Watch the clearance on grid line 4. Set it down easy, boys.
Hold it there. We need to check the alignment before we set it. Reading steady. Bring it down another 5 thousandths.
Your penetration here is insufficient. We need better fusion for the rocket structure.
Okay, so I need to increase the heat slightly.
This structural ring requires re-inspection before it moves to staging.
Noted. I'll update the hold status immediately.
The surface finish must be absolutely perfect on these channels. RA value maximum 0.4. We are running the fine pass now, Dr. Schmidt. It looks good.
Challenging to its location. This specialized thermal coating allows the nozzles to survive temperatures exceeding 3.5.
Clearances look good on the optical readout.
Transferring to the balancing rig now. Needs to hit 3,000 RPM.
Continuity check on pins 1 through 20.
All circuits verified. Solder joint looks clean under magnification.
This coordinated industrial effort demonstrates American manufacturing capability, meeting the stringent German engineering specifications required for these vessels.
BN2 フローを貸し台。
発令の手を書き出してください。
Thrust structure integration. Checklist item 4B.
Verified and signed off, Supervisor. We are go for the next stack.
Step 3B, verify voltage at the vacuum tube array.
Reading 250 volts, right within tolerance.
T-minus 60 seconds and counting. All systems go for propellant load simulation.
Confirming tank pressure is stable.
Roger that. Proceeding with final checks.
We've addressed the nonconformance as outlined here.
How does this compare to the German acceptance criteria?
It's fully compliant now.
Very good.
All structural points padded and secured.
Confirmed. Checklist is complete. You are clear for transport.
Crane 1, engage power, slow lift to clear the flat car.
Roger that. Moving up steady.
All systems are nominal post-transit.
Quality assurance accepts the findings. The rocket is clear for rollout.
Okay, easy now. We are lined up on fixture 7. Confirmed. Lowering into mounts. Level 2, confirm umbilical connection secure.
Confirmed. Green light on the panel. Proceeding to pressurization checks.
T-sequence start. Propulsion status.
Yeah, propulsion is green.
Guidance. Confirmed trajectory.
Confirmed. Launch. Oxidizer transfer is stable. Flow rate holding steady.
Copy that. Down to tank 1 level, reaching 90. Get your good. Over. Continue load.
Radar confirms target lock. Tracking steady.
Altitude 20 miles. Velocity is increasing as expected.
The pressure differential is within acceptable parameters.
Engine shutdown confirmed. Sehr gut.
Apogee tracking solid. We are fully ballistic.
The data confirms our projections. The structural integrity held up remarkably well during re-entry.
Looks like we have everything we need for the analysis.
The guidance performance was flawless. The comparison matrices confirm it.
Excellent work, gentlemen. We can confidently move to expanded production.
Are we certain of the projected delivery schedule?
Yes, the assessments confirm we can meet the targets.
Then proceed with the authorization.
This massive investment in indigenous rocket manufacturing capability builds upon the foundation of German engineering established here decades ago.
Precision is paramount for the integration sequence.
Herr Schmidt, are these measurements within tolerance?
Let us check the documentation again to be certain. Precision is paramount for the integration sequence.
Herr Schmidt, are these measurements within tolerance?
Let us check the documentation again to be certain. Precision is paramount for the integration sequence.
Herr Schmidt, are these measurements within tolerance?
Let us check the documentation again to be certain.
We need that panel aligned before the next shift.
Crane is ready for the lift on Bay 3.
The American platform shows significantly less drift than the captured German models.
A direct result of the refined calibration procedures.
Master arm, verify green.
Green, sir. T-minus 30 seconds.
Hydraulics stable.
The aerodynamics are improved, yes, but the fuel mixture ratio will need adjustment.
We've accounted for that in the new injector design, Doctor.
The improved injector design allows for significantly higher chamber pressures, boosting thrust efficiency.
Indeed.
We must monitor the combustion stability closely.
The theoretical calculations match the empirical data, Doctor.
And the material compatibility is excellent.
Displacement is exceeding the predicted values.
Look at the stress gauges on the weld line. It's starting to crack.
The vibration profile matches the updated specifications derived from the flight data.
The structural integrity is holding well within.
We are go for simultaneous ignition on stands 1 and 3.
Acknowledged. Ignition sequence start.
Telemetry looks good. Proceeding with accelerated schedule.
These V2 schematics are highly complex. We need to standardize the terminology before microfilming.
Yes, the American manuals must be unambiguous for production.
The Soviets are clearly ahead on the heavy lift capability, leveraging the V2 far beyond what we projected.
This impacts the entire strategic balance, General.
Provide. The gyroscopic control of the aggregate 4, or V2, was revolutionary for its time. And understanding
The turbopump assembly is critical for consistent fuel flow. Now, if we look at the nozzle here, the
V2 established the foundation. We adapt the trajectory for orbit.
The Soviets are close. We must accelerate Project Orbiter.
T-minus 10, 9, 8. We have ignition. Liftoff confirmed.
Congratulations, gentlemen. A magnificent achievement.
From wind tunnel tests to the static firing of its powerful engines, the Jupiter showcased America's strategic...
We've proven the technology works, General. The Jupiter is ready now.
This is about strategic control, not just the heart.
The F1 engine ignites, generating an astonishing 1.5 million pound thrust.
The transformation was complete.